This is a very short and conceptual section. The bottom line is enthalpy is Q. So let's get started and try to convince you of that. So enthalpy is symbolized by the capital letter H, and it represents the heat that is transferred between the system and the surroundings during a chemical reaction. And we'll get into the constant pressure in a moment. We cannot measure the absolute value. We can only measure the change in enthalpy, and that is why we have the delta. It is a state function. So reactions that are carried out in beakers, they're normally open to the atmosphere. So essentially there is constant pressure. So if I use my definition of internal energy that we talked about earlier, I have the term Q, and Q is going to be the energy transferred as a result of a temperature difference. We showed those pictures of a beaker on fire and a solution freezing. So we know there's going to be temperature differences. What is W? Well, W reverts to delta PV. And since work is being done by the system, it gets a negative sign. And since pressure is constant, it is pulled out from the change. So when we substitute back in, Q has become QP, and W has become a minus P delta V. That takes us to the definition of the enthalpy. Now, when you have a definition, you have that triple line. That signifies definition, and that's beyond the scope of this course. So what you see is the letter H, which stands for enthalpy, by definition is E, the internal energy, plus the product of pressure times volume. So what we do, since we know that enthalpy is a state function, we make a change for delta H, change for H, a change for E, and a change for P times V. We said on the previous slide that pressure will be constant, so this equation reduces down to delta H equals delta E plus P delta V. Now, on the previous slide, we defined the change in internal energy as QP minus P delta V. So what we'll do is we will replace delta E with Q minus P delta V. And that gives us the definition or the derivation of change in enthalpy is really heat at constant pressure. You will never have to define this. We had to derive this when I was taking Gen Chem years ago. But at this point, we want to get across the point that when we talk about a change in enthalpy, we're talking about the heat that is involved in a chemical reaction. So I just have one more slide to finish up this section. Enthalpy H can be thought of as heat content. The change in enthalpy is the heat that is absorbed at constant pressure. One point. Another point is every pure substance has an enthalpy. They're listed in the appendix. We'll be seeing them a little bit later in this chapter. And every enthalpy is a state function. Even if you take something like 1 gram of water at 0 degrees, you've specified the state, and 1 atmosphere, you specify the pressure, it will have an enthalpy. And that'll be coming up later in this chapter. You simply cannot determine the absolute value, but you can determine the change. There's always many questions after this section. People say, I just don't understand what it is that you said. But if you are going to be a science major, I've had so many come back junior, senior year to say, this finally makes sense. So I'll just say, please trust me. All right. Now, the other point that people may bring up is, what about this PV work? Well, the only time you have PV work is when you have a gas reaction, and that would be zinc when we dropped acid on it in chapter 4. You will never be called upon to take these things further. This is simply, the section is to tell you there is a term called enthalpy. It is a state function delta H, and it is represented by Q. The next section talks about calorimetry, and calorimetry deals with Q.